So this lecture is on exception handling. So when an exception occurs in your program, it's just some sort of piece of code that throws an error that you weren't planning on. And there's lots of different types of exceptions that can happen in your program. There can be a divide by zero exception. So if in your code you try to divide by zero, it's going to break your program. Or if you've probably seen by now that if you don't validate user input properly, so you're trying to, do a convert.2int32 on a letter, for instance. Well, that's going to throw an exception. That's how .NET handles things that are going wrong. You could also have, system out of memory exception that could occur. And so what you want to do is have a mechanism to where you can handle exceptions and not have your program crash. And this is important because think of maybe a program that's on an assembly line. We go back to like a car manufacturer. What you don't want to have happen is that just because an exception, divide by zero, or maybe you couldn't get to a network, so there's a network down exception, something to this nature, you don't want your whole program to crash and shut down the assembly line. What you want to have happen is, hey, this exception happened, my program handled it, I then logged it, alerted the user, and I returned my program to some sort of safe state. And so whatever that means, maybe it just resets it back to its initial state of everything and it starts, putting on car doors again or does something with the assembly line, that initial safe state. And so what we can do in C# is we can use things called try-catch blocks, which we'll take a look at now in the syntax. So anything you put within that try-catch block will handle an exception that gets thrown inside the catch part of the block. You can also add on a finally block, which will always get executed whether or not an exception occurred within your try statements. So now, when an exception gets thrown, it gets thrown and caught as part of the exception class. So this is the syntax for a try-catch. So you'll notice we have our try and we have our catch here. Inside this catch statement, this is where it catches the exception that gets thrown. Well, exception is the base class for all other types of exceptions. So for instance, there is a format exception class, there's a divide by zero exception class, there's a memory exception class. There's all these classes that derive from this base class exception. And so you can put any of these in here. So for instance, format exception. But any class that I put in here has to have been derived from the base class exception. So if you just put exception here, then that will handle all types of exceptions. So now with exception handling, what you generally want to do is you're going to have to handle different types of exceptions. So what I've done here is I've created just a method that gets passed into it the class where the exception occurred, the method where that exception occurred, and the message. So what happened? Was it divide by zero exception, network was down, system out of memory exception? And then this method here, you'd probably create this in some sort of special class. I'm just going to alert the user either by showing them a message box or outputting that to a log file. So this is where in your, real world example, you would actually write this out to a database or a log file, and then you'd probably give the user some sort of nice friendly error message because they wouldn't want to see all this class names and method name information, but an end developer would. So you would want to put that types of information in some sort of error log. So now let's go ahead and jump into the syntax now and write some of our code. So we're going to come up here, and what our code is going to do is I've got the single button click that will call this method button click, which is going to call method 1, which is going to call method 2. Inside method 2, it's going to generate an exception that's going to bubble up to method 1, which will bubble up to this button click where it's actually handled, and we actually call this method here to write it to our log. Now, there's an important concept here that we need to remember. What we do when we're handling exceptions is that any method like method 1 or method 2, so these are the type of methods what I call lower level methods. These are always methods that are going to be called by other methods. Or there's a top level method like button 1 click. So any method that's these lower level methods, so any method in a class you create, like a tic-tac-toe class, like is winning move, is a tie, they're always going to throw the exception or raise the exception up. They're never going to handle the exception. Now, top level methods like a button click, for instance, that are never going to be called by other methods, this is where you're going to want to actually handle the exception and call methods like handle error. And so let's walk through that. So let's first open up button one click and let's write a try catch finally block here. So I'm just going to type try, and you'll notice that there's two code snippets, and one does happen to be a try catch finally. So tab tab, and it's going to go ahead and put this try finally block in here for them. Then I'm going to go ahead and add in my catch part of here, and I'm going to say exception ex. And so this is where my exception handling is going to take place. So inside here is where I write my normal code, so let's call method 1. And so what this is going to do is it says, okay, I'm going to try to do all of the code in between these brackets, and if any of them throw an exception, it's going to be caught by this catch statement here. And so if method 1 has an exception, it's going to get caught in this block here. And oh, by the way, I always want you to execute this code. So this finally block is where you would put things like closing an internet connection, closing a file connection, any code that you want guaranteed to always run whether or not an exception gets ran up here. You always want to execute your finally block. Now, I want to talk about why I'm using this base class called exception. The reason I'm doing this is because any type of exception that gets thrown here will be handled by this catch block. Now you can also have nested catch blocks, or sorry, you can have different types of catches. So for instance, let's do a format exception. And so what this is going to do is it's going to say, okay, if method 1 throws an exception, it's going to say, is that exception of type format exception, yes or no? If it is, it's going to execute this code. If no, then it's going to always be handled by this upper level base class exception handling type. So you can have as many of these as you want. You could have divide by zero exceptions, format exceptions, and you could make them as specific as you want. Now I've heard different opinions on how you want to do this, and so I want to give you both sides of the story, because everyone seems to think they have the right answer. I've been to conventions with Microsoft talking and other top companies talking about how you should do this, and everybody seems to think you should do it a different way. So I generally will just do it this way, where I'm always just using the base class, and then I can handle all types of exceptions. Other people go by the philosophy that you should never even have a try-catch block unless you know the specific type of exception that can be thrown. Again, everyone's going to have their opinion. At your work that you end up working at, they're going to come up with some sort of style guide for coding standards that you have to follow. And this is something you'll have to decide on based on the trade-offs. And so, for instance, if you put a try-catch block or nested try-catch blocks in a method that you're going to run over and over again, and you care absolute about speed, these try-catch blocks can slow down your code ever so slightly. So if you want to optimize your code and you're calling this one particular method 10 million times and you need to execute as fast as possible, you probably wouldn't want to put a try-catch block inside of it. But now, generally speaking, most of our methods execute so fast with these user interfaces that we don't even care. So I just go ahead and put try-catch blocks in them, and I just go ahead and handle at the base class exception. So again, that's why I'm doing that here. So now inside of our catch, we can go ahead and just call this handle method. And I'm going to do that in just a second. I'm going to get back to writing that in just 1 second. So now let's go to method 1. So we open that up, and so now inside method 1, we're going to want to write a try-catch. So let's type try, tab, tab. And so here's our try-catch block. We just need to add on our variable here. And so now, because this is a method that's going to be called and not a top-level method, we know that we're going to have to raise this exception up. So if something bad happens, we don't want to handle it. We want to raise that exception up. And we do that with the throw statement. So what we could do is we could even just say throw EX. And that would do is that would say, hey, just throw the exception from method 1 to any method that called it. So it would actually be caught right here. So we're throwing the exception, and button 1 would actually catch it in this exception handler here. Now what I like to do is I actually like to pass along some information in my throw statement. So what I like to do is I like to throw and generate a new exception and then put some exception information into it. So what I mean is this. So if you were to throw this exception here, it would get raised up, and then you could catch it here, and then you could pass it to this method here, handle error. Now inside EX, you can say EX dot, and you'll notice that not only can we get data associated with the exception, but we can also find the message, which describes the current exception. We can also get the source, and we can also get a stack trace. And we'll take a look at what the stack trace gives us in just a minute. But this actually tells us where that exception occurred, which is probably a piece of information we'd want to write to the database. However, we're going to create our own user-friendly stack trace, and I'll show you the difference in just a second why I'm doing this, and it'll make more sense. So I want to create this user-friendly stack trace. So what I want to be able to do is, so when they look at the log, they can say the way this exception was occurred was the user clicked this button, which then called method 1, which called method 2, which called method 3, which called method 4, and so they can get a perfect trace of how this exception occurred. And so to do that, what we do is we say throw new exception, and now we want to pass up information into our exception. And so you notice one of the overload is just we can pass up any type of message we want. So we could say, exception handle, occurred in method 1 or something to that nature. But what we want to do is we want to be able to do this dynamically. What I mean by that is I don't want to hard code that method 1 is where the exception occurred inside this particular class that I'm in. So we're going to use a new concept called reflection. So if you notice up here at the top, I added in this using statement called system.reflection. And these classes that are inside this reflection namespace allow you to reflect upon the current executing program at runtime. So while your program is executing, you can get information about the current running exe, or you can get information that, for instance, which method or class the current code is executing in. So what I can do is inside that reflection namespace there was something called the method info class. And what I can do is I can say method info.get current method. And so this gives me a reference to what current method I'm executing in. And so what this is going to do is you can see it's actually going to return me a method base. And so this gives me a handle to some information about method 1. And so what I can do now is I can say dot declaring, I could say just dot name, and this would give me the name of the method 1. So this would just throw up an exception. It would say, hey, your exception occurred inside method 1. But what I really want to do when I raise this exception is actually say something like, hey, this exception happened in form 1, method 1. And that way the developer who's debugging this knows exactly where this problem occurred. So instead of name, what I want actually to do is to get the declaring type.name. And so this right here is going to return me a string that just says form 1. And so using reflection, I can figure out which class this exception occurred in. And so now what I can do is I can concatenate on some special characters like a dot. So I can say it occurred in this class, dot, and then I can tack on method info dot get current method dot name. And so now by doing this, it's going to say class 1 or form 1 dot method 1. And so now again someone knows exactly where that exception occurred. And then what I'm also going to do is I'm going to put some made up special characters here, and then I'm going to add on the current exceptions message. So let's scroll back over here and let's go ahead and put this on a couple lines here so it's a little bit easier to read. So you can see what I've done is I've gone ahead and I've said, okay, give me the class name dot method name. So it'll be form1 dot method 1. And then, oh, by the way, tack on whatever type of exception actually occurred here. So this will say, format, invalid format, or divide by 0, something to that nature. This will be the specific exception message that occurred. And so by doing this, I've now created something that I can just copy and paste into all of my exceptions. So now let's go ahead and call method 2. So that's all this method does. So method 1 calls method 2. So now let's take a look at method 2 now. So now in the code of method 2, you'll notice that I create int j as set it to 0, and then I say 5 divided by 0. So this is guaranteed to throw an exception. So this right here will throw an exception. It'll get caught by this exception handler, and now we're going to build ourselves a new exception. And it's going to say form1 dot method 2 divide by 0 exception, and now it's going to throw this exception up, and it's going to be caught right here. And then this is going to say, okay, now I'm going to build me a new string. So this is going to be form1 dot method1, and then it's going to tack on this message, which is what I created right here. So what this does is it builds a little, little trail. So what we can do now is we can say, okay, when I look at this, it's going to say this exception occurred by clicking this button, and then method 1 called method 2. And so that's going to create this little breadcrumb trail leading up to here. And now at our button 1 click, what we want to do is this. I'll just paste this in. So we can see now we're actually going to call this method called handle error. And if we take a look at handle error, it says, hey, pass in the class, the method, and what message you want to output. And so all I do is I just pass in, okay, this is the class name, this is the method name, and oh, by the way, here's the exception I want you to show the user. So let's go ahead and run this, and I think it'll make a little bit more sense. So the first thing I'm going to do is I'm just going to run it. It'll hit that breakpoint, and I'll just hit F5 to go through here. Let's take a look at this exception message now. So you can see what it did was it says, okay, your exception occurred at form1.button1click, so the user clicked the button. This method then called form1.method1, which called form1.method2, and the exception that occurred was attempted to divide by 0. So now if you were to write this out to a log, you could see a developer could come in here and say, okay, what exception occurred, a divide by 0, how did it occur, okay, here's the path, so I know it occurred in this method, but to get to this method, there'd be 100 different ways that this method actually got called in all kinds of different places, but here is the direct path so that hopefully we can reproduce this particular bug. So see how this is kind of a good little breadcrumb trail that I've created. So it's a very readable stack trace. Now remember, there was also that stack trace property, which we'll take a look at now. So let's go ahead and run this. Let's get rid of this one. Press F5. So here's where our exception is going to happen. So we press F10, and sure enough, there's our exception. And you'll notice as I press F10 here, now this exception, I can take a look at it, and it says attempted divide by 0. Here's our source, and here's our stack trace. So if I open this up, here's the generated stack trace, which you might also want to save to your database or file. And we can see it happened at chapter 3 exceptions, which is the namespace in our form 1 in method 2. It actually gives us the entire file that it happened in, and it also gives us the line of code. So it doesn't give us that full breadcrumb trail like we'd like. So again, this is a helpful piece of information, and we may want to save it away also. But by looking at this, you can probably see why I liked that more user-friendly, and I wanted control of how I reported that and saved that to my end developer trying to debug it. But this is also kind of helpful. It just doesn't give us all the information. So again, under EX, you can see that, here was what that message, here's the source of it, here's the stack trace, and all of the the type of information we can get. So now let's come in here, we build our exception, it gets raised up now, and now it's handled by method 1. This is going to get raised up and be handled by the button click. So we hit F10 again, and you can see sure enough by the button click, then it comes in here where we actually handle the error and now write this out to the database or present it to the user in a user-friendly way. So now with your assignments, this is what you're going to have to do. And it's really easy. So for every new method you create, so you say private, every time you create a method, you say private void my method, the very first thing you should do is just say, okay, I'm going to have to copy and paste some try-catch block code. So you copy, paste, again, we'll delete this. And so every new piece of code, the first thing you do is you just copy and paste this in here, and your exception handling is done. And we've built it dynamically. We haven't hard-coded, which method and classes they're in. We're using reflection to do this. And then next thing you always do is comment your method. And there you go. You've got your method stub already done. You just write your code in here, and your exception handling is taken care of for you. Then, so these are all your normal methods. Then in all of your methods that are like button clicks or any top level methods, you'll add in this type of try-catch. So you'll just simply copy and paste this, and then you can write your own little handle error method and then write your code in here. And so you'll do that for all of your assignments now to make sure they have exception handling.